Storing token in server side is convenient, but sometimes there is an overhead of maintaining data storage, Redis in previous example. There is another alternative for token validation using stateless tokens that would allow us to get rid of the token data store. Stateless tokens means we don't store token in database or any other storage. Instead, we can create and secure the token data and send it to client. Client will be responsible to keep this token and use it during next API requests. All required data, along with how to validate data, is exists on the token itself, so no data store required on server. Fortunately, there is a standard way to create stateless tokens using JSON Web Token or JWT or JWT. In simple words, it is a string consists of 3 parts, each part separated by dot. First part is header, second part is payload, and third part is signature. The header is a JSON object containing information about how the JWT signature should be computed. In this sample, there are 2 fields for header JSON object, type, which value is JWT, and alg, which shows hash algorithm to create JWT signature component. In this example, we use HMAC SHA-256 to calculate signature. The first JWT token component is base64 encode of this JSON object. Payload is JWT component, which is JSON that contains claim data. This data is used by consumer to claim that this information belongs to consumer. There are several standard claim fields as defined on RFC 7519 about JWT. We can also add as many custom claims as we want. Note that this payload is not the payload for transaction data, but payload used for JWT token. These claims must be validated on the API side, or if using API management on API management side. In this example, we have 2 claims: the issuer of the token and the token expire date in epoch time in second. Epoch time is a number of seconds since January 1, 1970. To calculate epoch time, you can use online tools like epochconverter.com or time library on most programming language. The second JWT token component is base64 encode of this claim object. In signature, the third component, we have the first 2 parts of JWT, which is base64 encode of header and base64 encode of payload with dot to separate them. This component is hashed using algorithm in header part and encrypted using secret key for specific consumer. Unless someone has the secret key, they cannot decrypt this information. So this is where JWT goes secure. In this example, we hash using HMAC SHA-256 algorithm as defined in header, and the secret key is my secret key 123. The third JWT token part is hash string in base64 encode. Using previous example, we will get JWT token like this. This JWT token can be calculated by using libraries or online JWT calculator. See website jwt.io for calculator or list of libraries for many programming languages. We can attach this token as authorization mechanism. In this case, we can use HTTP authorization header with value bearer token. Being widely used, JWT also provides standard fields for first part, the header, and also second part, the payload. Being standard does not mean we have to use all of them. Some fields are optional, and we can also add our own field, usually on the payload part. These are standard fields for header. Notice the note on yellow rows where using the fields will make JWT vulnerable. We will discuss about it later. This is some sample for header. Note that fields order is not important. Notice the green sample where we use key ID or key ID field. Also, notice the red sample where we put the HMAC key on the header field JWK. Let's talk about the blue sample first. In these two samples, we tell the server to validate JWT token by using particular HMAC SHA algorithm specified in ALK field. The HMAC secret key only known by server, and it is server responsibility to secure the key. This is the easiest use of header. It is a good practice to change keys regularly or use multiple keys. When having multiple keys for HMAC, we can put the keys on server. This can be file, database, etc. For each key, we have key ID. On the JWT header, we specify which secret key to use for HMAC on KID field. JWT specification also provides two standard fields, JWK and JKU, which basically to tell the server, use the secret key or you can retrieve secret key in this location. Using these fields means we give secret key, something that's supposedly secret over the network. So an attacker that intercepts the communication will easily retrieve the valid HMAC key and reuse it to generate fake JWT tokens. Although HTTPS can secure some part of this, it is useless if attacker herself is valid user and intercept traffic from her own computer. Since HMAC key generally same for all other tokens, having one secret key for attacker can be enough. That is why using JWK or JKU means making JWT token vulnerable. These are standard fields for payload. These fields usually called as claims. Pause the video for a while if you want to read the details. Other than the standard payload fields, or usually called as standard claims, we can also have our own fields, depends to our own need. It is called as private claims. For example, we can have these private claims. In the payload, we have several fields for time validation, not before and expired at. Since we talk about networks, there might be a clock skew or time difference from one node to another. This time difference can mean one node's clock is faster or slower than the other. For example, client clock is currently 10:19, but server clock is already at 10:21. Server is responsible to validate these time fields. During server validation, it is better to give time tolerance to handle the clock skew. This tolerance should be no more than few minutes. This time tolerance is usually called as leeway. This is some sample for payload. Note that fields order is not important. Basically, we can use any private claims, but does not mean we have to put all of our business fields in JWT tokens.